Greetings for the day, dear students. Today I'll discuss the topic metal ions in biology. This is my second lecture on this topic, and today I'll cover essential trace elements, and I have divided this topic into two subparts. Today I'll discuss the part 1 of this topic. So let's start essential trace elements that is included in the topic metal ions in biology. So what are trace elements? Here I will give you the introduction, the classification of metal ions in biology, individual trace elements, and the conclusion. Now, naturally occurring homogeneous inorganic substance required in humans is in amounts less than 100 milligram per day. Minerals for 5% of our diet. Essential trace elements are iron, zinc, copper, cobalt, chromium, fluoride, iodine, manganese, molybdenum, and selenium. And probably essential trace elements are nickel, tin, vanadium, silicon, and boron. Non-essential trace elements are aluminium, gold, barium, bromine, lead, silver, mercury, rubidium, strontium, titanium, and zirconium. Now let's come to the essential trace elements. We can divide them into two categories, trace elements and ultra trace elements. So in this lecture I will cover the trace elements, which are iron, zinc, and copper, and the part 2 of this lecture I will cover ultra trace elements, that are manganese, selenium, cobalt, chromium, fluoride, iodine, and molybdenum. So first we will take iron. Iron is the most essential trace element. The body content is 4 to 6 gram. In hemoglobin it is about 68%, and in ferritin it is 13%, and hemosiderin it is 12%, and myoglobin it is 3%. In iron enzymes it is about 0.2%. Now we will see what are the iron dependent enzymes. Cytochrome oxidase, xanthine oxidase, and peroxidase are the iron dependent enzymes. The body requirement is, daily requirement is 0.5 to 2 milligram per day, and 3 to 5 milligram per day is required during pregnancy. And the daily excretion of iron from the body is 0.9 milligram per day and 1.5 milligram per day during menses. Now what are the dietary source of iron? The dietary source are leafy green, whole grains, beans, pulses, liver, spleen, and mollusks. Iron is absorbed in ferrous form, which is measurable in blood as free iron. Now we see what are transferrin. They are transport protein. It binds to 2 iron molecule and transports iron to various organs and tissues. S iron plus total iron bound transferrin minus total iron is this total iron in circulation. Its determination of transferrin gives TIBC. Transferrin can be measured by RIA, ELISA, and chemiluminescence. Now ferritin. They are proteins having 24 subunits, binds to 4000 iron molecules. The measurement used to assess iron stores in the body. Ferritin levels may be seen in hepatitis, cirrhosis, hepatic sarcoma, also in leukemia and NHL. RIA and ELISA chemiluminescence are it is measured through these methods. And normal iron absorption in metabolism is shown here. So here we can see the daily diet contains 10 to 20 milligram iron, and it goes through various processes, and here I have shown the different percentages. Now the deficiency state of iron. It is asymptomatic weakness, headache, irritability, and varying degrees of fatigue and exercise intolerance. The treatment is 6 to 3 milligram of elemental iron per kg per day. Oral preparations of iron. These are ferrous sulfate, ferrous fumarate, ferrous gluconate, ferrous succinate, iron calcium complex, ferric ammonium citrate. What are the adverse effects of iron? The adverse effects are epigastric pain, nausea, vomiting, gastritis, metallic taste, constipation or diarrhea, lipid preparation, staining of teeth. Liquid preparation is staining of teeth. Parenteral preparations. It is as iron dextran, iron sorbitol, citric acid complex. Adverse effects being pain at injection site, pigmentation, fever, headache, palpitations, and anaphylaxis. What are acute iron poisoning? 60 milligram per kg elemental iron. It causes vomiting, abdominal pain, bloody diarrhea, shock, dehydration, cyanosis, acidosis, coma. The treatment are gastric lavage with sodium bicarbonate solution, desferrixamine 15 milligram per kg per hour to at the max 35 milligram per kg per hour. Correction of acidosis in shock. It fails dialysis. Now the second trace element is zinc. It is the second most abundant trace element. Cofactor of DNA polymerase, alkaline phosphatase, and carboxypeptidase. It regulates growth, immune system, collagen synthesis, wound healing, bone metabolism, reproduction, taste, smell, and vision. It reduces the time period of diarrhea. High dose of zinc prevents dysmenorrhea. Zinc is required in producing testosterone. It is used for common cold and in treatment of warts. The body content being 2.5 gram, 60% of in muscle, 30% in bone, 10% in body tissues and organs. Its daily requirement being 3 to 14 milligram. Diet rich in zinc include red meat, fish, seafood, pumpkin, cashews, beans, and dark chocolate. Now, what are the effects of zinc deficiency? Its deficiency causes leukemia, cirrhosis, hepatitis, sickle cell anemia, and malnutrition. The symptoms are in children, growth retardation and skeletal abnormalities; in adults, smell and taste, appetite, skin lesions, and hair loss. Zinc deficiency is also associated with ectodermatitis, enteropathica, and anorexia, esophageal squamous cell carcinoma, cognitive and motor impairment, diarrhea, and pneumonia. The treatment is zinc supplements 45 to 100 milligrams per day. Now, the next trace element is copper. It is the third most important trace element. Diet rich in copper include red meat, shellfish, water pumped through copper pipes, and the body requirement of copper is 80 to 120 milligram. 40 to 60% is absorbed in duodenum. It is transported through metallozymes, for example, ascorbic acid, 90% bound to ceruloplasma, 9% to albumin, and 1% is free. Body content of copper is 80 to 120 milligram. Now we come to body functions of copper: erythropoiesis, nerve conduction and immune functions, fertility to maintain pregnancy, act as a catalyst for copper containing enzymes, for example, tyrosinase, ascorbic acid. It is toxic, the toxic range being 5 milligram per kg, adequate 34 micrograms per kg, and deficient less than 8.5 micrograms per kg. RDA is 9 to 1.3, 0.9 to 1.3 milligram per day. The deficiency symptoms of carbon are fragile hair, depigmented skin, myoneuropathy, edema, hepatosplenomegaly, osteoporosis, anemia, and neutropenia. Now we see the Menkes disease. It is congenital X-linked genetic disorder and mutation in ATP7A gene. Inactivating mutation in this gene causes copper deficiency. What is Wilson's disease? It is autosomal recessive disorder. Mutation in ATP7B gene causes excessive accumulation of copper. Clinical features are diarrhea, vomiting, cardiac and renal failure, hepatic necrosis, and encephalopathy. The treatment is lifelong treatment is required for this, and avoidance of high copper diet. In early stages, zinc may be effective as it compensates with copper for absorption and penicillamine. So this was all about the essential trace elements, the part 1 of this lecture. Thank you. Have a nice day.